Namaste, this is MSc third semester class of physical chemistry and topic is photochemistry. Photochemistry is the branch of chemistry which deals with the rate and mechanism of reaction taking place due to the exposure of light in between the range of 2000 to 8000 angstrom. The reaction which can be brought about the light radiations are called photochemical reactions. The term radiation include radio waves, X-rays, gamma rays and also beam of particles like alpha particles, neutrons, electrons and protons. The study of photochemistry helps us to know the changes when a molecule absorbs radiations. Now we discuss about the difference between photochemical and thermal reactions. In photochemical reactions, these reactions involves absorption of light radiations. In thermal reactions involves absorption of or evolution of heat energy. Photochemical reactions takes place in presence of light is the primary requirement. These reactions takes place in light as well as in dark in thermal reactions. In photochemical reaction, temperature has very small effect, and in thermal reactions, temperature has significant effect. In photochemical reactions, delta G may be positive or negative. In thermal reactions, delta G is always negative. Photochemical activation is highly selective process. Thermal activation is not selective in nature. Now we discuss about the absorption of light. When a monochromatic or heterogeneous light is incident upon a homogeneous medium, a part of it is absorbed, a part is reflected and remaining is transmitted. We can write I0 means total amount of energy or light energy. I0 is equals to IA plus IR plus IT. For comparison cell, IR is very small, so we can write here I0 is equals to IA plus IT. In photochemistry, we concerned with absorb light. So now we discuss laws of photochemistry. Draper law. First is only those radiations which are absorbed by a reacting substance or system are responsible for producing chemical change. According to this law, all light radiations are not bringing the chemical reaction. Some are increase the kinetic energy of molecules while some are re-emitted. So, next law is Lambert Flow. When a monochromatic radiation is placed through a homogeneous absorbing medium, the rate of decrease in the intensity of radiation with thickness of absorbing medium is directly proportional to the intensity of the incident radiation. So we can write here dI upon dx is directly proportional to I. When we replace this proportional sign, we put a constant k. So minus di upon dx is equals to ki. Now we can write this reaction di upon I is equals to minus k dot dx when we rearrange this reaction. On integration above reaction, we can write in this manner, and when we solve this reaction like this, finally we get that I upon I0 is equals to 10 to the power minus AX, where I0 is initial intensity before passing absorbing medium. I is equals to intensity after passing absorbing medium, and A is extinction coefficient, X is thickness of absorbing medium, and I upon I0 is equals to transmission or transmitting. Log I0 upon I is equals to AX shows absorbance or optical density D. The next rule is Lambert Flow. According to this rule, when a monochromatic radiation is passed through a solution of absorbing medium, the rate of decrease in the intensity of radiation with thickness of absorbing medium is directly proportional to the intensity of the incident radiation and concentration of the solution. So here we add a new factor, concentration. So we can write this rule as minus di upon dx is directly proportional to IC, where C is concentration, and we solve this reaction like this. Finally we get log I0 upon I is equals to D, and I0, Ix and epsilon are given here. What is this? Next rule is Stark-Einstein Law. According to this rule, each molecule of absorbing substance absorbs one photon of the radiation in primary process. Now explanation of this rule is a molecule acquire energy by absorbing photon as A plus H nu is equals to E star. Thus energy of proton is E is equals to H nu. So we can write here so E is equals to NHC upon lambda. When we put these values in this reaction, so finally we get E is equals to 1.1962 into 10 to the power 5 upon lambda joule per mole. A mole of photon can excite a mole of molecule, but if electromagnetic radiation are extremely intense, molecule may absorb 2 or more photons A plus 2 H nu A star. Hence this rule is not valid for all conditions. Now we discuss about the quantum yield or quantum efficiency. It is defined as the ratio of number of molecules reacting in given time to the number of quanta absorbed in the same time. So psi is equals to number of molecules reacting in given time upon number of quanta absorbed in the same time. We can write this relation like a rate of chemical reaction upon number of quanta absorbed in the same time. So now determination of quantum yield. First is reason for unique quantum yield. According to Einstein Law, the photochemical equivalence law in primary process, each molecule absorbs one quanta, hence quantum yield is unity. Reason for high quantum yield, psi is greater than 1. Then the product of primary process may collide with second molecule and transfer energy second to third and so on. Thus chain reaction starts and a number of reacting molecules will be high. Due formation of intermediate product which act as a catalyst. Exothermic reactions may activate more molecules, and reaction between hydrogen and halogen. When a reason for low quantum yield, in some reactions deactivation of activated molecules takes place and the primary process before transfer to product. The product of primary process may react back to form reactants and decomposition of HN and Br, polymerization of anthracene. Factors which affect the quantum yield. All primary photochemical processes endothermic, hence quantum yield increases with the temperature. We know energy absorbed by molecule is inversely proportional to wavelength, hence quantum yield will be higher at the lower wavelength and vice versa. As the speed of photochemical reaction is proportional to intensity of light, hence quantum yield increases with intensity and vice versa. The addition of inert gas in photochemical reaction, the quantum yield